everyone and welcome back. In the previous video, we understand the main characteristics of problem-based learning and its impact on students in the higher education context. Now, we'll look more in detail on how to apply it in the STEM teaching, starting from a practical example and showing the kind of activities for each step. Let's start. As we already know, the pre-problem-based learning focuses on the solution of problems related to real situations, engaging students in active construction of knowledge. There are several models describing the process of problem-based learning, but it's summarized in 3 steps. Identify the problems, explore information, solve the problem. In the step Identify the problem, students are involved in the problem definition, clarifying all the unclear terms and concepts, and then in the analysis of the problem. In the second step, Explore information, they conduct research on that problem in order to generate possible solutions. One important element is to recognize the knowledge deficiency linked to the problem presented, since it represents the learning issues that students research during their self-directed learning. Finally, the last step, Solve Problems, aims at applying the knowledge acquired, verifying the designed solution or solutions. Similarly to the inquiry-based learning, the conclusion includes a metacognitive activity, that is the reflection on the abstract knowledge gained and on the process to reach it. One feature shared by inquiry-based learning and problem-based learning is their cyclical structure. In fact, the last step of problem-based learning can lead to a lack of proper solution for the problem or further elicit other problems. So, the process of facts identification, generation of solutions, and verification can start again. The method foresees an active role of teachers during its execution, facilitating the process by supporting students during the activities. This support translates into specific actions. For example, since problem-based learning is a method in which students construct their own learning, teachers can help students in identifying learning objectives or the strategies to solve the problem posed, especially in the case of problems with multiple possible solutions. In the first part of this video, we will explore the structure of problem-based learning method. Now, we will apply the PBL process through a concrete example. The scenario is adapted from a study by Ramcharan and collaborators in the field of chemistry within a Bachelor of Science program. This collaborative problem-based learning activity centers on the topic of polymers, with a particular focus on polymers and environmental pollution. In the initial phase, students are asked to identify the problem. To do so, they research materials related to the classification, structure, and properties of polymers. For instance, they may choose to focus on a specific polymer, such as plastic, examining the patterns of plastic consumption and recycling in their own country to define the problem of plastic waste. In the following phase, Explore Information, students search for possible solutions through group discussions, make interdisciplinary connection. At this stage, it may be helpful to use visual tools like graphs, diagrams, or tables to organize information and uncover links between concepts. The outcome of this process is a student develop a solution. For example, in this case, a set of guidelines for managing plastic waste. After identifying this solution, students are expected to apply their new acquired knowledge to address the problem. The proposed guidelines could be reviewed by experts in the field or tested by the students themselves to evaluate their feasibility. Finally, each group presents its solution to the others, prompting a reflective discussion on the overall problem-based learning experience. As reported, this example shows a case of collaborative problem-based learning. The group work is in fact a key feature for this kind of strategy, able to foster the process of knowledge construction and increase students' engagement and motivation. In fact, the problems that students are asked to solve can also present high levels of complexity that must be solved from different points of view. Therefore, group work becomes a necessity. A study by Smith and colleagues highlights that collaboration is an essential part of problem-based learning, allowing students to promote communication, negotiation, and metacognitive skills. As is reported by Ranieri, problem-based learning is also suitable for implementation in online environments. In this regard, the essential elements to transfer this approach to an online environment are the presence of teachers who acts as a guide, the division of students into small, medium-sized groups, maximum 5 or 6 members, the assignments of roles within the groups, the preparation of an environment that allows synchronous or asynchronous communication between participants, as chat, forum, with specific communication rules, the presence of clear instructions. In this perspective, the online environment could support the synchronous and asynchronous discussion between group members through forum or chat or through video conferencing platforms. For example, in the context of the identification of the problem and searching for solutions. While the online repository can support the sharing of materials or the collaborative creation of sketches and diagrams. In conclusion, problem-based learning is a valid method to support learning, motivation, collaborative and problem-solving skills in the context of higher education. Important elements to consider for its implementation are the guiding role of teachers and the collaboration among peers. I hope that this video was inspiring for your teaching, and I encourage you to implement this method in your teaching practice.